So in our last lesson, we talked about trig functions and their graphs. Today we are going to talk a little bit more about trig functions, in particular about how we can transform these functions. So we've talked about transformations of graphs before, and so some of these will look similar to what you already know, but some of them will be a little bit different. Okay, let's start with the amplitude. Now, the amplitude, as you can see in the examples that I've just put here, we have y equals sine of x, y equals 2 times sine of x, and y equals 5 times sine of x. So the value of a is the number that's in front of your trig function. And we call this the amplitude. Now if you were to go ahead and graph these on your graphing calculator, just to see how they compare, you want to make sure you're in radian mode. Here's your sine of x function, goes up to 1, down to -1. Okay. And then next we have y equals 2 times sine of x. Now in this one, instead of going up to 1 and down to -1, it's going to go up to 2 and -2. Now notice that as it goes up to 2 and then down to -2, it still crosses the x-axis in the same place, at pi, at 2 pi, at 0, at -pi, at -2 pi. So just a thing to notice. So the last one, y equals 5 times sine of x. This one's going to go all the way up to 5 and all the way down to -5. And then again, notice that this function is, again, still crossing the x-axis in the same places as well. All right, so here is the summary that you can write in the box there. So we have y equals a times sine of x, and the amplitude is going to equal the absolute value of a. Now I put the absolute value of a there because if you have a negative out in front, that's going to be a different type of transformation. So just make sure when you're using a, it's really just telling you the absolute value of a gives you the amplitude. All right, let's continue. We're going to talk about the period of the function. So what happens to the graph when b equals 2 or b equals 1/2? Where b, as you can see in the examples I've put here, is the number right next to the x. Okay, so y equals sine of x, we'll draw that out again. So going up to 1, down to -1, and one cycle of the graph is equal to 2 pi. Now again, you can go ahead and graph these on your graphing calculator and compare all of them and see what you find. What you should end up finding is y equals sine of 2x is going to give you a similar function, but instead of having one length of the cycle be equal to 2 pi, one length of the cycle is only equal to pi. So this, because the cycles happen at a shorter length, that means you can fit more cycles. You can fit twice as many cycles in the length of one of the original cycles from sine of x. Now for the last one there, y equals sine of 1/2 times x, you may guess that this is going to change the period by making it a longer cycle. So rather than a cycle being the length of 2 pi, now one cycle is going to be the length of 4 pi. So this is what that last one looks like. And another way to think of the period is to think of it as a horizontal stretch or shrink. All right, so in that box up top, let's go ahead and write this down. Y is equal to sine of b times x. And to determine the period of the function, you do 2 pi divided by the absolute value of b. And again, we're using the absolute value because a negative in front of the b is going to be a different type of transformation. So you'll notice for the parent function, the parent trig function, in this case sine of x, b is equal to 1. So if you were to plug 1 in for b there, you have 2 pi divided by 1, which is equal to 2 pi, which is the normal length of one cycle. Whereas with, say, y equals sine of 2x, right, if you plug 2 in for b, you have 2 pi divided by 2, so the length of one cycle, one period, is equal to pi, which is what we drew in there with the red graph. All right, next we're going to talk about reflections. There are two types of reflections that you'll see. So in this first one, we have a negative out in front of the function. When that happens, let's see, here's cosine of x. Then negative cosine of x is going to look like this. Now, what kind of a reflection do we have there? It looks like we have a reflection in the x-axis. Okay, so if you have a negative out in front, then that means there is a reflection in the x-axis. Okay, so on the other hand, if you have a negative on the inside of the function, so for example, y equals cosine of negative x, well, you might be able to guess this is going to be a reflection in the y-axis. Now for cosine, what does that look like? Well, here's my parent cosine function. If we are going to reflect that across the y-axis, well, in this case, because the cosine function is what? It's an even function. Remember that even functions have symmetry with respect to the y-axis. So, in fact, this is going to be actually exactly the same. It's not always like that. It's only because cosine is an even function that this works. If you had the function of sine and you reflected it across the y-axis, you would not have the same thing. All right, so in the box there, you can write y equals cosine of negative x is a reflection in the y-axis. All right, let's take a look at example 1. It says, give the amplitude and period of the following trig function. F of t is equal to 5 times sine of 4t. Okay, so the amplitude is given by the number out in front, so that's 5. And then the period, now remember the period is not given by b, but it's given by 2 pi divided by b. All right, so that's the one tricky thing about the period. So it's 2 pi divided by b. So that's 2 pi divided by 4. So that's equal to pi over 2. So the period of this function is going to be pi over 2. That means what? That means you can fit 4 times as many cycles compared to the original parent sine function. All right, next example. Describe the transformations that change the graph of f into the graph of g. Okay, so let's just start going through it from left to right. So that negative there, that indicates a reflection. Because the negative is on the outside of the function, this is going to be a reflection in the x-axis. Next we have the 4 there, that's going to change the amplitude. So it has an amplitude of 4. And then it looks like lastly we have that 1/2 in there. All right, so that's going to change the period. And remember the period is 2 pi divided by b. So 2 pi divided by 1/2. You can think of that as multiplying by the reciprocal. So that's equal to 2 pi times 2, which is equal to 4 pi. All right, the last example, we are going to be trying to graph from starting with the parent function and then graph the different transformations on there. So for all of these, I would suggest first by drawing in your regular parent function. Now notice here that originally we normally have it going from 1 to -1. Now in this particular example, because the amplitude changes, I'm just going to go ahead and take off those labels, but I'm still going to draw in the sine function as if I had labeled them. Now what's nice about this is that instead of having to draw more labels For the amplitude, what you can do is just change the labels from 1 to -1 and change them to 3 and -3. And then you've taken care of the amplitude that way. So that takes care of that. Next, we have that negative that's on the inside of the function. So that's going to be a reflection in the y-axis. So let's go ahead and change that. So a reflection in the y-axis is going to look like this. Okay. So that takes care of that negative. And lastly, we have that 2 in there, and that 2 is going to change the period. So the period, normally for a parent sine function, is 2 pi. But now that we have a value of 2 for b, that means that the period of the function is going to be 2 pi divided by 2, which is equal to pi. So this is going to horizontally shrink it down. We're going to be able to fit twice as many cycles in the length of one of the original cycles. So that means instead of going, if you start from 0, 0, instead of going out to the right to 2 pi to make one cycle, we're only going to go out to pi to create one cycle, and then from pi to 2 pi will be another cycle. So now this is going to look something like this. And that's it. We've taken care of all 3 of the transformations. The amplitude was 3, so we took care of that. The negative on the inside indicated a reflection in the y-axis. And then the 2 on the inside told us that the period was going to be 2 pi divided by 2, which was pi. So we horizontally compressed or horizontally shrunk our graph.